Hey everyone, this is Eugene, and together we're here together with Austin, Matt, Mike, and Jacob, and this is another episode of near life contract reviews, and today we're gonna review a contract that Matt created partially. So it's called Generate, and let's do a quick demo first. And I need to maybe give share options.
No, I got it.
Got it. Okay.
So I can start sharing my screen now.
Yeah.
Thanks. Okay, so this is Generate, like the app. So we'll just take a quick look at it first. Basically, it's going to allow people to create generative NFTs from code. You can bring in some packages, but that's not what we're going to talk about today. And we're not going to talk about like the syntax of the code. We're going to look at the contracts and how you take a series, which is basically like a class or a blueprint for an NFT, and you create, you put it up for sale, and then people can mint one of those series with particular parameters. So in this case, this is Conway's Game of Life, and the minting parameter for this example is going to be the seed parameter. So what I'm going to do is I'm going to go ahead and I'm going to create this series right now. So I'm just going to call it like sand. I don't know, just for fun. I'm going to put it up for sale for a price of 1 NEAR. It's going to redirect me again to the NEAR wallet because I'm not actually signed into this contract. That's the source code going up now. So it's like in the first transaction, I actually paid for the NFT and I paid for the space to store the source code. And then the second transaction, which normally happens behind the scenes, was actually taking the source code and putting it up because it's too big for the wallet redirect URL. So anyway, if I go to series that are available now, one of these isn't rendering properly. It's just WebGL error. Sand is basically a series now. And I can purchase one of the sand tokens for just 1 sec, sorry. I don't know why this link isn't working. I don't know. Oh, it's weird. Okay. I think maybe it's the all caps sand. So I'll take my caps lock off. I'm going to make a new one of this. Sorry. I don't know why that's not working. I'll have to look into that. But let me just get to the minting process because then you'll see I can use that seed variable to mint a unique version of this NFT. So go to the market. This series lowercase sand, I don't know why that's not working, but basically you choose like a seed variable, so 2. So that's going to create a unique combination. So you'll see like you can kind of eyeball it from these spots here. The seed of 2 is different than a seed of 1. So that's just Conway's Game of Life. So let's mint this token. So that gives me a unique NFT. So up until now, no NFT has been created. It's basically just a series inside the NFT contract that is available to be created. Whoops. Let me go to my collection. So I should only have sand 0 here. So that's 1 sand token. I'm going to go to the market and I'm going to mint. If you try to use seed 1, it'll say, you know, a token with these values exists, try another combination. So basically, you have to mint with a minting argument of 2, and then we'll put them side by side and we'll see how they're different. And because it's enforced on chain, these minting arguments, basically the resulting, you know, artwork, if you can call it that, are different. So there's sand 1 and there's sand 2, and as they sort of kind of like animate, you can see that they're actually, you know, different pieces of quote unquote art. So yeah, so code-based tokens, and eventually you can create variations that are unique. And that's basically the demo.
Cool. Yeah, that sounds looks pretty cool. So what's new based on the NFT standard for
So in
this?
the NFT standard, all we really define is we define basically what it means to be a token. And we have defined things like token metadata and how to transfer tokens. And we have some callbacks for putting tokens up for sale. The differences here are that I introduce kind of a concept called a series. And a series is not in and of itself a token, but it sort of describes a group of tokens. So basically a series has, certain things like a max supply that can ever be created and things like this. And then we don't have to get into the specifics of like these minting arguments and owner arguments and things like that. That's for my particular project. But I think that the basic definition of a series with a max supply, defining like a group of tokens, is something to look into. And then from the series, there has to be a way to approve a sale of a series. And then that should kick off a callback to the marketplace contract, which has a series on approve. And so if you've approved a marketplace to sell a series, the marketplace basically needs to list that as a sale and probably like customize some things, because when you actually purchase a series on a marketplace, you're not just transferring an NFT, you're actually going to call the NFT contract and you're actually going to kick off a minting of an NFT. So those are the differences there.
Okay. Yeah, let me share the ID. Okay, I think you should see it fine. So where should we start? I think the default one is pretty much the same. It basically a standard NFT contract, like with serious stuff.
A lot of the additional data structures are simply for like bookkeeping and record keeping and like the practicalities of like actually showing the different tokens for series, things like that on the actual app itself.
Cool.
The arg hashes ones, so mint arg hashes and owner arg hashes for the series, those are to enforce the uniqueness of the NFT. So if you mint with a particular minting argument, I cannot mint one out of the series with the same minting argument. And likewise, if we both own the same token, there's arguments where the owner can update owner arguments. So basically, if you own the NFT, you can change like the background color to red, then you transfer it to me, I can change the background color to blue. But if the original series creator chooses to enforce this, and again, it's optional, you and me cannot have the same background color at the same time. So there's kind of like a bit of fun sort of ownership and sort of game mechanics around there.
Okay. Let's go. Okay, we have the initialization, measuring some storage. That's all standard. So you can have a set contract royalty.
Also want to give a shout out to Austin because he took a pass on this on Saturday morning and kind of helped to clean up some of the storage key stuff. I was still using like the old syntax and I had a lot of like try 2vec stuff everywhere.
Okay, let's basically go to, I guess, where do you want to go? Series? I mean, where's the
series is probably the place to go next.
So a bunch of arcs. Mint and owner. What is the string here? Is it account ID for the owner?
No, those are the owner arguments. So basically,
I
it's
got
going to
it.
be
Yeah.
like they're just basically arrays of arguments. So they're just args passed into some piece of artwork, some piece of code.
Okay, cool. Series args and series params.
And just to confirm, those strings would be like JSON serialized strings. Is that correct, or am I misunderstanding that?
Yeah, they could be. They could be just like they could be any value really. So, but if it was some JavaScript array, for example, it'll be JSON stringified kind of string.
Yeah, gotcha. Cool.
What actually happens in the application itself, and by the way, I'm looking for feedback on the best way to do this, but what actually happens in the application is that the source is loaded into an iframe, but it's regex replaced with what comes from on-chain. So basically just loads the template that the artist laid out, and then it just basically like searches for the matching mint or owner parameter, and then by name, and then it basically swaps it out for the values that it has as arguments from the actual NFT token. So the only thing that the NFT token is carrying around with it is the unique arguments for that particular token, just as an array of strings. And it, of course, it's got to be kind of like parallel to the name array of series args, or sorry, series parameters. But basically, when you bring a series down from the chain with its source code and its series parameters, and you bring the arguments down from the chain for the NFT token, you put them together, and you basically can produce the source that the user technically owns, based on the on-chain data.
Do you, what it's called? No, like sanitize the input so it cannot be like pure JavaScript sticked into this?
I JSON stringify everything, but
okay.
I don't sanitize it on the near side, like on the contract.
Well, not on the contract side, but on the client side.
Yeah, on the client side, I just basically have taken the tact of like stringifying everything, and then just doing JSON parse when I unload it.
But you can get a string and like stick it into JavaScript somewhere, probably. Anyway.
Yeah, there's a risk there.
Yeah.
I think actually, when I actually go live, what I'm going to be doing is I'm going to be actually passing the iframe source. I'm going to actually load it to another domain using my API helper. And then basically, when the iframes are loaded, they're actually going to be cross origin. And then in that way, there shouldn't be, even if there was malicious sort of minting or owner arguments in there, you shouldn't be able to jump out to the parent. Right now, it doesn't work like that, but that was actually brought up by Vadim last week, is that every iframe that's displayed should basically be cross origin, just to protect the users against someone who buys a token and then injects in some JavaScript.
Oh yeah, because it can be like any JavaScript, not just like malicious argument insert. So you can pretty much mint it, malicious JavaScript potentially. So yeah, it has to be within the iframe. Cool. Anyway, let's go back to the contract. Okay, so you have series create and approve. Get a series name, bytes. Is this a size? Or?
Yeah, so you just like in token, I can't remember the name of your project, Token Factory or
Yeah.
Token Farm. So basically, you have to pay for the storage of the bytes of the source code that you want to actually be a part of the series, and then that that's a wallet redirect. You pay your near, and then you come back, and then you're allowed to call series. I can't remember the name of it, but it's like series update source or something. It's further down, but it's a non-payable method where you get to put in source that matches the bytes.
Cool. Okay, params, series params, account, royalty, message. And the message goes to, oh, okay, yeah, it's to send series and approve to the series owner ID. Okay. Calls it to account ID. That you pass. Okay. Oh, that doesn't really check this, that you attached enough storage, because you do saturate in sub. Shouldn't you just overflow? Like, make sure you attach enough storage?
So you're saying allow the overflow, and then
No, well, you can put a cert here, for example.
Right.
So you can put that you attached enough storage, something like storage.
Oh, I see. Otherwise, it's letting you create the series, but then it's not listing it on the marketplace. But you're technically have created the series, because I didn't do an assertion here.
Yeah.
Okay. Yeah. Good call.
I probably don't have Rust FMT enabled.
Yeah, the reason why I'm letting you deposit a little bit extra too is I want to obviously go all the way through to the sale contract and like pay for storage and just list it. I was trying to get this down to the point where for the user, despite the fact that you have to kind of come back and behind the scenes, you're going to update the source code, it should feel like just one wallet transaction.
Yep, makes sense. Okay, so yeah, it calls series and approve, gives the name, the owner ID, and the message. And also insert create internal. That takes series name, bytes, params, royalty, and puts it there. Make sure that there's no series. Hashes series name. Bytes. What if there's a okay. So yeah, it cannot be a set already, because it should fail there. Then you do get series per owner and stick that there and save it. Yeah, that's such a common pattern, and like with the, I think question with what you're doing with like get mute or something. That would be like one liner. Like maybe.
Oh, I just meant on that like subtraction before. It was before what you're talking about now.
Oh. I mean, for this particular piece.
Oh, I see. Yeah. It is. It will be, I guess, made a lot easier to not have to do that manually.
Do you have entry for another set or something like this? Have you tried this interface for only for the vector?
The
Oh.
entry API is only for maps, but so like I will do that once I get to the maps. But yeah, it's entirely possible once you have the caching layer. So yes, like in the future, hopefully that will be the case, but I'm not sure when. I'll have time to work on that.
So what we're talking about is basically in Rust, if you have, let's say, a map, a hash map, and then you have something like account ID account. And then you should be able to do entry, and then you say, for example, well, I guess in this case the key has to be cloned, but owner ID, and then you can do or insert with, and then you can insert something like this inside. And you can then do the inner operation, which is this insert. So the entry represents an object that either already pulled from the map or created a new one. And then you just, once it's dropped, so once this piece goes out of the memory, out of the scope, that will reinsert this entry back into the original map M. So that operation will be done and the scope drop, I think.
Yeah, it's probably a little bit out of the scope of this contract review though, because that probably won't be in the like stable API for a while.
Cool. Okay, so you added internal. Let's go up, more up. Okay, here. Then you get the series by name and make sure the owner of the series is the predecessor, and then add the approved account. So you don't have the approval ID right here, Matt, for this operation.
Sorry, beg your pardon?
Do you have approval ID for series? Like similar to NFTs?
Yeah, the approved account IDs. But I don't have a nonce because yeah, I didn't use a nonce. And I can't remember what I was thinking when I did this. It was a couple of weeks ago, but I felt as though a series was basically going to go on sale predominantly on, you know, one marketplace, maybe multiple marketplaces, but normally somebody's just wanting to add an approval for a marketplace to sell their token, and then the marketplace can sell their token up to the max supply of the series. So I feel as though the mechanics, for some reason, I felt the mechanics were different, that all you needed was basically to be an approved marketplace. I'm not sure about this though. I'm not sure if this is the same.
Okay. Okay. Maybe it's okay. Okay, series create to this similar method except no approval. And you have a refund deposit here.
I think one thing I could actually just get a bit of a improvement upon is if series create internal return series, then in series create and approve, I could avoid having to like go get it again. I think I do that. Yeah. But I don't know if that's necessary.
Do you need to refund deposit here? You said you don't want to refund extra.
That was for series create and approve. I want to pass the excess to the marketplace contract. I do want to refund the the excess near to anyone that's paying, like, so if the bytes are, the bytes are going to cost you 0.2 near and you send me like a whole near token, I want to give you the rest back. I'm trying to do the best I can here. I changed the refund deposit method because sometimes I don't want to pay back. I don't want to pay back to the predecessor contract. I actually want to pay back to, the person who
makes sense.
Called the method.
Okay. In this case, you're basically not refunding the extra if the message is none. Do you want to just like always require this message then?
For series create and approve, it goes to the marketplace contract, and then any excess that's not used there from this amount will actually be refunded back to
I mean, like, if the message is none, then you basically just keep it.
That's a good point. Good point. Yeah, I probably should do that. I'm making notes while you're doing this too.
Cool.
So, thanks.
Okay, so this one we already looked. Series approve. So this one is approves a given operation. Yeah, so this one is fairly similar to what we already did. So maybe just copy this.
But in series approve, is there the same problem where if it's none, then you're not actually getting a refund?
Yeah, you're also not checking the enough deposit.
Right.
Okay, series update. So this is where you provide the source code.
Yes.
Okay, getting the series by name, unwrap or panic. Well, that sounds like expect. But you, okay, you basically don't want to panic if, like, maybe you don't want to format the panic. Owner equal to predecessor. Then if source, you can only update the source once. Then the source should be equal to bytes. Then you change the source and put the series back in.
By the way, thanks, Eugene. Your comments were why I ended up with this method in the first place. When I posted about a week ago about the
Cool.
URL transactions to the wallet being too long.
Yeah, I mean, yeah, we should figure out something. So one way you can potentially improve this is merge source with bytes into one argument, because you don't really need bytes if the source is present, and you don't need source if the bytes are present. Like you cannot have source, so something like, in theory, it should be an enum that is either a source or bytes. But yeah, that's separate. So you can have maybe like source size. And then here you would have just this, right, without bytes. So when you initialize it, you give either source size or source. And then when you check, you read it, and anyway.
I follow. Yeah, I think that's a good little kind of tweak, because I mean, yeah, if you have one or the other, you don't need the other.
Token specific method, update token owner args.
Yeah, so these arguably could actually be moved to their own file. So it could be something like, like token updates or token specific methods. But basically, if you're an owner of a token, you have the option to update the owner arguments, and this is the way you would do that. And then you have to pay for any additional storage that you occupy. So for example, like an owner argument could be a URL. So like somebody could have a series that represents like a JavaScript video game. And if you are a owner of one of the tokens of the game, you could actually create an instance where you have defined game artwork for different characters, for example, like avatars or sprite maps or whatever. And you're linking out to these different URLs. Some of them could be really long. So you're going to occupy a lot more storage based on just the arguments. So that's why we're charging for arguments as well.
So yeah, makes sense.
And I hope I'm doing it correctly.
Okay, yeah. One thing, because you reuse this, like getting series by name, maybe it makes sense to create internal getter that like unwraps it, so you don't need to put panic in every place. Okay,
does it make sense? Does it make sense to have internal getters for like, token data by ID, series by name? If they're all gonna always kind of panic and basically say, no token name, things, or token ID.
Yeah, it makes sense to have it if you want to have a custom panic, right? You can obviously just say, okay, just unwrap. And then you probably don't need a internal getter because you just unwrap. But if you have the code that formats the token ID, then you would avoid having this type of copy paste where you need to put the more complicated argument twice, potentially.
Well, like each one's a little bit different though, so I don't know if it would really save you that much.
Well, I mean, series by name is probably repeated here, so you can have this. Maybe you can also do like assert owner ID, or like assert owner's predecessor in the same method, but not necessary. Yeah. Here you don't need to assert.
I think I just realized something about this. I don't think I'm even asserting that you are the token owner here. I think I was so obsessed with updating the series properly that I don't think I actually made sure that you are the owner of this token. So
yeah,
there's a good one that
enforce unique arcs. So but do you remove the old arcs or not really? Like here. So if you update in the arcs, do you create a new token? You just replace it, which means you cannot go back to the original arguments.
No, I don't actually want people to go back to the original arguments. I'm not gonna keep out like a history. So I think there's been some updates to this.
I mean you don't delete the current argument. So if you like
in the hash
from hashes, yes.
Right. Oh yeah, that's a great point. Okay, so basically you choose the color red. I can't choose the color red. You change red to blue. I still can't choose the color red.
Right.
Okay. So this was because it doesn't actually show up in the minting case, because the minting is like a one-time operation. You choose your minting arguments and you're done. Once you've minted, you can never sort of update. So this is kind of a little bit of new logic that I'll kind of have to tackle and get rid of the existing hash. But that's easy enough. Like before I actually update the oh, and I'm inserting into the series mint arg hashes and not the owner hashes. Great, awesome. Fantastic little copy paste there problem. Okay, so I'll make some notes about that. It's a good thing it's a good thing I didn't launch yet. You guys could have had a lot of fun.
You can also separate join arcs a bit different. Maybe with something that is not part of the standard arcs, because there can be conflicts. Like if you have two arcs, then like let's say first is 1 and second is 2, 3 for some reason, and then you replace them with one, 2, and then 3, assuming you don't have spacers. Like if the strings are not separated, then you might have like an issue having two arcs like this that would conflict.
All right, yeah, I understand what you're saying. So basically
like two numbers.
I should introduce like a custom delimiter, which would make sure that like each set is unique.
Yeah, like comma. If it's JSON, it should be fine.
Sure. I mean, it doesn't really matter as long as it's the same and it hashes, right?
Well, the problem would be like two numbers. Let's say two arguments. One of them is like you would put 1 and second is 23, and like JSON serialization is just this. And the second would be 12 and 3, and that can be conflict.
Yeah.
And maybe here you want to probably have like a colon as well. So your series are not conflicting.
Okay. Got it.
Is there not a like actual hash like functionality exposed in the environment? Like this seems kind of weird to like create it as a string and then hash it like this.
Yeah. Well,
I just by the way, I'm just overloading this hash account ID function from the NFT core. So
Gotcha.
It's used for creating like internal storage keys, but I just decided it was super convenient.
Yeah.
And I mean, there's nothing enforced like in the account ID type. There's no length of the account ID or anything really, any validity enforced. So I'm just basically smashing in big strings because
I'm just trying to think of how we can make a better interface for that though, because like you're doing unnecessary logic that you don't have to do like through the formatter, but it just doesn't matter.
Yeah, you would have something like series args for hashing. Then you'll do like name. And then owner args. Or maybe just args. And then you'll give just an array, and then you use Porsche or something for this. So you'll do try to vec wrap. This way you will get U8 array that is kind of takes care of serialization of this. Cool. Yeah, so you need args or the owner args here. Then you set the owner series args is owner and mint. Insert token data. Okay. I guess you don't really need to do this, right? Because you already have this in token data, so you don't need to get serious from. Oh, yeah, you need to enforce unique owner args parameter. Okay, never mind. So again, you're doing saturating sub without asserting the division. So instead, you want to have something like checked sub, and then expect not enough deposit. So it actually panics here if you don't have enough. And then never mind. Okay. So basically, you're not refunding if you decrease the size of the args.
Yeah. Basically, if you increase the size of the args, you have to pay, but if you decrease, it's not going to refund. I'm wondering if there's like a more elegant way to do this. I don't know.
You can probably do two arguments for this method. One is like initial, one is final, and then it will figure out whether you need to refund or ask for the refund. Or ask for the more deposit. So you don't need to write it here.
So you put under refund deposit, you pass in like an optional original bytes.
Yeah, something like this. So just like whatever, just initial and final bytes. Okay, series supply keys as vector links. It should have links on the map. You don't need to get keys as vector. So we can do this. Series data. Getting series by name. JSON. So basically, if this is just a single method without any other arguments, it would make sense to do into. So you can implement something like impl from series for series JSON. And then you do this. And then you basically can do here, you do dot into, and Rust will figure out how to cast it to JSON. Here you can also do dot into. Even so, the compiled code is likely identical. This is kind of more Rustish way of doing it.
Yeah, another way. I haven't looked through the whole code itself, but you could also maybe avoid doing the whole conversion altogether and just have a like custom serialized implementation, or just have it like derived with annotations that like call the function. Because I think the only thing that you need is just the fact that the account IDs is coming from an unordered map to a vector, or like a storage vector to a vector.
Yeah, you basically keep all of this already, and then you just do 2vec.
Yeah, where like I think you can just do that with like either just a derived Serde annotation, or you could just do a custom Serde implementation, and then you don't have to do this like in term type and have to like manage both of them and make sure they're the same. Just an idea. Like it isn't.
How you actually can make a custom without wrapping it?
Well, you can just have like implement it manually without doing the derive, or you could, or like there is the I'm pretty sure there's an annotation for, like you can serialize and deserialize with a specific module or function. Like I don't want to like bike shed this contract review. Like I can either do it later or just like talk about it, how to do it later. It's a very small point.
Mm-hmm.
No, but this Austin, this small point, you have no idea how much like copy paste this small point is saving me.
Okay, well then maybe what I can do is I'll find some time to just like create an example to do some of this stuff, just so that it's like you can just easily do it again. Maybe if it's really useful and it's something that other people would use, we can maybe think about putting it under the SDK somehow.
Yeah, I think it's super common to like where you have all the arguments are the same, and then some of them you're just skipping, which is probably you can do certain skip, but some of them you actually need to translate, but you don't want to write a custom implement, like custom serializer for the entire method, because well, Third doesn't provide nice interface for this. You need to like think hard how to do this.
But Austin, it's implemented like everywhere that the like our Rust collections are exiting out to to JavaScript. So basically, unordered map, lookup set, all of the stuff, like everywhere that we want to just simply have a view method pop up and just get like the object that contains like a lookup set when it has to exit to go to the client, like, I mean, and get serialized, it's just a nightmare because you have to.
Yeah, I hear that. Yeah, and then it should be pretty easy to just create some like custom implementations that handle these common types, and then yeah, I'll experiment with that maybe today or tomorrow or whenever I have time, because that could be like a very big.
But also a lot of stuff is like, well, I maybe like my bytes here, I U64, and I just want to do like capital string, like string deck 64, something like this.
Yeah, that would be nice. Okay, so you don't have to do like you go through the wrapper for sure.
Yeah. Okay.
I mean, realistically though, like approved account ID is, by the way, another one you guys didn't catch, but I was catching it while I was looking at it, is there's no way to remove an approved account for a series. So however, again, like I'm thinking about series logic as though you're going to list it on a marketplace and then you're going to basically sell out the entire series, and then that's it. That's the end of the story for the series part. And then there's like, let's say the series was 50 tokens, then there's 50 NFTs floating around, and the NFTs are the real things that you want people to own. The series is just there as a single source of what are these tokens, what is the source code for these tokens, what are the parameters of these tokens. But once the sale is done, it's done. If you don't mind, Eugene, like, maybe just for 5 or 10 minutes, if you don't mind just going to the NFT callbacks in the market contract, I'd love to look at the on approve for series. It's below. So I created a different receiver here, like a different trait, and I call it like the non-fungible series approval receiver. I'm not saying I'm going to come up with like the standard here, but basically I think that we should start to think along these terms, that many more people will do lazy minting, like many more people will define token types and then want to list them up for sale. So we'll have to come up with something in the next sort of month or two. But basically this is what happens when you send like a series in. It's very similar to actually the NFT on approve. And maybe just a style thing or like an opinion. It's pretty weird, but I drop the token type on the sale. I say that the token type for the sale can be an option. So I basically say the token type is none, but the token ID is the series name, because all sales are basically stored by NFT contract, some delimiter, and then the token ID. So in this case, I preserve the series name as the token ID, but it's a little counterintuitive because the series name is essentially the token type, like, or what is referred to as in most of the sale contracts as the token type. So it's a little bit confusing and like kind of janky if anybody has like opinions on that.
I'm not sure we can transfer 0 on a protocol level, so this might fail. So you may want to have an if there. So extra, like refund amount. So you may want to.
Is this further attacking my love affair with saturating sub?
No, I think this is fine here. Just this is, you may want to have this done that way, because otherwise you may have just promise failing, and it will generate a receipt that will be invalid by the protocol, so the entire method will fail just because of the like exact amount. But yeah, I don't think like saturating sub is an issue here, because you do potentially not sure what the storage deposit.
Oh yeah, my marketplace just basically runs on like fixed 1 kilobyte storage per sale, so there's not a lot of actual checking of bytes used.
Okay, well that may fail, right? Potentially, like if you somehow incorrectly did the attachment, like you attached not enough. So if you don't pay, then it will fail for sure. Okay, owner paid enough. Then you check sale conditions. That's fairly interesting that you parse in the message just not through the JSON, but directly knowing like the message is kind of standard for your case. So, which is not the way it can be in the contract.
I tried. So yeah, I had this recommendation from Austin over the weekend, and I tried to make it the actual. Oh, in this case, I made it sale args, right?
Yeah.
Yeah, I mean, well, it's coming from my contract, so.
Right.
But yeah, so Austin had this recommendation like, hey, why are you sending strings as messages, and then because they're going to get serialized and deserialized as strings, and then they're brought into the contract. And I understand the sort of the general purposing and like the opening up of somebody might create and approve a series but be specifying a different marketplace, in which case they'll have to call out with a string to the different marketplace or some different args. By the way, I went through so I think I left this because I had gone through all of the callback methods, and I had set them to be like kind of like actual types, structs for everything. And then I just got a whole bunch of warnings basically saying, no, this is a string leaving this contract, and it's actually the wrong type now that it's in a cross-contract call landing in the marketplace. So I ended up with a whole bunch of crazy stuff. I think I left the series on approved stuff though as sale args. But I mean, what's the recommendation here? If I were to consider this to be like, if I were to sort of be working within my own kind of like pseudo standard that was open up to everybody, I should really just be taking in a string here, and then I should be actually deserializing it inside the method, right?
Yes.
Okay. Austin, you got any comments about that? Because you and me, we kind of went back and forth about that on the weekend.
Oh, that makes sense. Yeah, I didn't consider the point you just made before. So yeah, that makes a lot of sense. Like ideally, it would be nice if, okay, so like there is kind of another option, which is just that like the format of the deserialization is just like a value, which could be ambiguously anything. And so that you deserialize it once, and then if you do want to like infer its type, you can just convert it from that value to the type that you want. Like that is another option, but like I don't think it matters very much. So I think the way that you have it is fine. It just seems a little bit weird to like serialize it as a string and then deserialize it like into a string and then into whatever type it is. Like it seems a little bit weird, but I think it's fine the way it is.
Yeah, the reason I think we didn't took the value is which is maybe, I actually don't know. Yeah, the value would be okay too. The reason is we wanted to support more formats for messaging. So we wanted to like have it Borscht, but then it has to be valid JSON. So for Borscht, we're like, okay, you just pass base 64 string. But
yeah,
having like actual value makes even more sense because you can pass like any data there.
Yeah, I mean, I guess there could be some sort of like format or like standard that we can build on top of Borscht where it allows this like ambiguous decoding. But yeah, you kind of do need like something that is like self-describing format like JSON or like CBOR for binary or stuff like that. I think BSON is pretty similar. But yeah, like it definitely doesn't work too well with Borscht if that is part of the standard.
We do support something like JSON value, like value from Serde. Imported it, yeah. So I wonder if like actual our NFT or our like near bindgen will be able to take the argument just pure JSON value.
Yeah, I would say it's maybe possible, but we may not want to tie that type so specifically to like the JSON value. You can just create like your own type, and then we can like implement all those things if this is something that we want to have as a standard. Yeah, I'm just throwing out ideas. I don't have any like preferences. I just think it makes more sense to like just have it deserialized once.
Well, one thing we want to, well, JSON doesn't really support this very well anyway, is just unparsed argument. And you usually use it as pass-through. You like take it in and then you throw it to some other callback directly without parsing it.
Yeah.
So in this case, JSON value seems fine. You probably can do this, but then
that might be a little bit hard to kind of manage within the near bindgen, like having that case specifically. But I mean, I guess it's not impossible.
Okay, we're a bit over time, so let's finish this method and to see what else we need to do.
The rest of it's actually pretty standard in terms of inserting the sale. I'm wondering if we could just jump in the last like 5 minutes, if we could jump back to NFT core, because there's been a modification to NFT transfer payout. And this is where the memo field comes in from the sale. So the offer is made on the sale contract and the promise, the NFT transfer payout is called from the marketplace. Sorry, offer comes into the marketplace. NFT transfer payout is a cross-contract call. And then this is where, based on the memo, we're going to be either minting the token or not minting the token and just doing an internal transfer. So just this first bit here, where it says,
yeah, that's a bit weird to reuse memo for something like this.
Sorry, it's a bit what?
Weird to reuse memo for something that is logic driven. And the reason for this memo is just a free-form login string. So you drop it in a log without parsing it, at least in the standard. So for this, you may want to introduce some custom logic, like. So you want to actually introduce message instead of memo.
Yeah, message.
Okay. No, that's good. Thanks.
Bunch of options here. It's kind of weird. Anyway, so you get parse it, or like attempt to parse it. And then mint series, mint args. lazy mint true. And returns you owner and no payouts. So why reuse it then if you don't do payouts for the minting?
I plan to do that. Actually, I plan to pay out the series owner, and then I plan to add additional royalties for the NFT token minter. So I plan to kind of merge it all together, but I just haven't gotten there yet.
Okay.
So I want to do NFT transfer payout. I want to pay the series owner, like, I guess I'm presumably, 100% of the first sale. And then I want to add, well, I'm going to add additional royalty people in the NFT mint.
Okay.
So sorry, I guess your question was why call NFT transfer payout? Why not just call NFT transfer?
No. Like I saw the empty map of the list of the payouts. Then I was like, why calling the payout if you don't return any payouts?
Oh yeah, I just think I haven't gotten to it. I think because also like a series could be created with like, I think like a series has royalties as well. Anyway, long story short, I want a series to basically be able to have like 1, 2, 3, 4 different artists, and then I want a token purchaser to also specify mint arguments and be able to add themselves if they want to the royalties, going forward. But I haven't really I haven't been focusing on royalties at all. I don't even have it in the UI. So
what's the, okay, cool. So why do you use option boolean if you don't use the value? Is it because you want to also be able to call it without this argument?
Yes, actually, that was why. And I know that that's not like the official 100% like Rust way to do it. But basically, I use this in a couple of places where I just have an option bool and I either have it or I don't.
Okay, cool. I guess you don't need bool. You may use like empty. I'm not sure how JSON gonna serialize this.
Well, no, because no, it'll serialize it as basically null. But like you still need the true and false, don't you? Or do you not need the value?
I don't use the true or false. I use option set or not set.
Oh, so, I see. Yeah, so that open close will serialize as null. So I don't think that really solves the issue.
No, I think null is still passed. Undefined is not passed. So if you pass a null object, then it will be there. Anyway, you probably just want to have a separate internal NFT mint and then a wrapper.
Right.
Yeah. To be like better readable.
Sorry, yeah, that's
anyway. Anything else you want to take a look before?
Yeah, actually, one last thing. Over the weekend, I actually spent like an hour and a half on Sunday talking to a partner about a exploit in the marketplace contract. I just thought it'd be kind of interesting to show. So it's been updated already, but I can still speak to the exploit. If you go to where is it? It's in the NFT callbacks. If you go to the first the NFT on approve, it's fixed in the series on approve as well. So here's what happened, and I want to run this fix by you, Eugene, as well, just to double check the fix. Okay. So what I had originally is I had like a cascading series of basically bad sort of things, three to be specific. So one of them, I was checking the sales storage for the owner ID that was passed in from the NFT contract. 2, I was only checking the storage for one sale, but that was, like, did you pay enough for one sale? Okay, fine. Then you can add as many, like you can add any subsequent sales. That is obviously been fixed here. If enforced signer storage is enough to cover +1 sale, +1 more sale. The third thing was something weird about predecessor and signer cannot be the same person. And this was weird because I was only checking. Yeah, I needed this method to definitely be enforced as the result of a cross-contract call. Otherwise, you could call it from the CLI and you could just post sales and like essentially.
Well, that's not really a fix.
What is this? Isn't a fix, and why? And why?
No, like you can still like fake it right through another contract.
Yeah, you can fake it through another contract, but for the sale, you're going to be listed as the you're going to be you can still list the token ID, but I guess you wouldn't be the correct NFT ID because I was using predecessor here is the NFT contract, and then token ID comes. Sorry, go ahead.
So signer ID should be owner ID that you pass. So instead of signer ID, you should always use owner ID.
But what happens if you're just calling NFT on approved directly from the command line and you're just feeding me?
Predecessor is different.
Right, but what if you have a middleman contract that's deployed? So what if you're calling from a CLI, you're calling a malicious NFT contract that's calling the marketplace, and you're pumping in, you're just feeding it owner ID values.
Yeah. So this is pretty common issue for the like all callbacks that we have. Like transfer call cannot take increased storage that is not paid. So for example, or what Refinance does, it's like you first register the predecessor, the token that you're willing to receive. Otherwise, anyone can give you a bogus token. And then you will blow up your account storage. So you're essentially asking a user first to kind of whitelist the token contract. So then the NFT contract is getting whitelisted for a given user. Now, if this token is calling on behalf of the owner ID, the owner should already have prepaid for all of this. And then you get you write data only for the whitelisted contracts. So the way it works is something like this. So first transaction owner calls marketplace and say prepay for NFT, or like there's two ways, common storage and separate storage. So let's say common storage, so you like prepay for storage. So second operation is owner calls marketplace and then calls whitelist NFT contracts. So this is where you say which contracts are okay to be listed on your behalf, like they are legit contracts. And then you call NFT contract that calls marketplace. This is method. So you call something like NFT transfer call, and then it calls, or like NFT approve. And then you call on approve. So this is approve. Very close. So on approve has a predecessor NFT contract. And because this contract is whitelisted by this owner, and owner paid for the storage for this, like for in general, this operation will succeed. So
but so what's the risk? What's the risk in the current implementation here? Like, what's the risk? Like, because if there is a risk of only the sale contract, like getting a bunch of bogus sales, but somebody actually paid for the storage for those bogus sales, I'm not so concerned about that. What I'm concerned about is I'm concerned about somebody being able to like just pollute the sale contract with sales and not pay for storage. I'm not so concerned about stupid sales that actually can't sell a token.
It's more like your owner calls Berry Club that calls marketplace unapproved. So that comes from the owner who called just Berry Club, and then marketplace just listed just tokens on behalf of the owner, like paid, like drain the storage of the owner. Like it's not as critical as like doing like something more complicated, but it's kind of annoying.
Wouldn't I have to just check that that signer ID equals the owner ID you're passing in, or is that just the same problem? That
no, the Berry Club can pretend to be an NFT, but it will be a bogus NFT.
Right, and then
which means
users are calling Berry Club methods, but they're actually getting their marketplace sales storage drained through this malicious Berry Club method.
Pretty much.
Okay. That's a long way to go for putting in like 10 or 20 bogus NFT sales.
Well, it's a probably not a big issue, and no one will abuse it as much unless you can somehow drain this storage later by like unapproving from Berry Club and getting the money back. But if not, then
I think in the first place, what I'm going to do is I'm actually just going to implement a whitelist of contracts in a lookup set that only the contract owner, myself, can actually edit. And then that way I can basically just bar any calls coming in from like any accounts that are not NFT contracts that I think are cool. I mean, it's annoying. It's like pretty annoying to update, especially if there's like thousands of NFT contracts.
Another issue is if you have some kind of automated agent here who do this. So signer is the owner, but it should be agent, because agent called NFT approve. The agent is the owner. So you have some DAO, right? You can have a DAO that owns the NFT but cannot get approved because owner has to pay for the storage of the approval, because signer ID is not the predecessor of predecessor.
Right, yeah.
Anyway, we way over time, but yeah, the way to address it is some kind of whitelist the contract in the marketplace first, like the accounts that can essentially do approvals. They can be either global whitelisted or user whitelisted. And then you trust the actual owner ID of this contract to be able to charge for storage. So what you do is like assert NFT something like self NFT whitelisted, and then you pass owner ID. and that method will effectively prevent some contract of doing it before it's getting whitelisted either by the owner or by the contract. So you cannot call it directly from the command line unless you paid for the storage. Okay, let's let me stop sharing. So I really like where the app is going with the series minting, because I think it's like a very cool use case that we don't have yet. So this kind of like NFTs that can be minted from other NFTs, some unique stuff, and like you can later potentially combine multiple NFTs into one NFT to create like a collage that also can be like extension of the series.
Yeah, thanks for taking the time to review. I'm eager to get this out and get this into the hands of some artists and stuff. Most of which will never understand what's going on in this contract review, but that's okay. We are just here to, to write this stuff up and protect them from my bad code.
All right, thanks. Bye, everyone.
Thanks.